Hello everyone, welcome to Study Guide for today. Again, we're going to be looking at a calculation that has to do with this is a more of volumetric analysis, the calculation that involve volumetric analysis. So in this calculation, I want you to pay attention to learn how to solve these problems, perhaps if you are having problem with them. So in this, at the end of if you are patient enough to watch the end of it, you will be able to see some other related questions in this that will help you, understand it more. So in this case, we have a question here. It says a solution of hydrochloric acid contains 0.57 gram or in 250 cm cube, 200 cm cube. 30 cm cube of the solution neutralizing 25 cm cube of sodium trioxocarbonate 4 solution. Calculate the concentration of trioxocarbonate 4 solution. Now in this case, you are calculating the concentration Now based on this, now you can see that they did not specify the one we're going to calculate. In other words, because they did not specify, the best you can do here is to calculate both the mole concentration and the mass concentration. So in this question, we gave us we have our chemical equation. Now if you look at this in very well, we find out that as area I want us to pay attention to this end, you find out that we have gram and this other one 200 gram. The first thing we're going to do here is to get the mass, then mole concentration, the mole concentration of the acid itself. So before we do that, now for us to do that, now watch what I'm going to do. We know that from that question, 200 cm cube of the hydrochloric acid contain 0.57 grams. Now we need to find out what it contains in dm cube or in liter. So we know that 1000 cm cube now we know that 1000 cm cube is something as 1 liter or 1 dm cube of hydrochloric acid will then contain 0.57 times over 200 times 100 over 1. So in that case, now what we do here is that this can cancel out this can cancel out this one. So what we have here will be 5. So in that case, since it's 5, we'll have our this seems to be 2.5 grams. That is the gram that is involved here. 2.85 grams. So this is what it contains. This is what is contained in 1 liter or 1 dm cube. Is that okay? So this is because most often we use liter or dm cube as a standard of measurement. So because we have it now, the next thing we're going to do here is to get the mole concentration, the concentration of the acid in mole per dm cube. Concentration of the acid in mole per dm cube. Since 1 dm cube will contain this, and we know that concentration is always amount over what volume, and this volume is always equal to dm cube, 1 dm cube or 1 liter, as the case may be. So in that case now, the amount is always mass over molar mass. Mass over molar mass. That means the mass of this divided by molar mass of the acid. The molar mass of our acid is already given to us. This is 36.5. That will give us 0.078 mole. Then when you divide by 0.078 mole divided by 1 dm cube, we have it as 0.078 mole per dm cube. That is what we have. mole per dm cube here. So now we can now go ahead to solve the problem. To get this problem solved, we always use our formula, which is so in this formula. The next thing we're going to do now, where this stands for, the 0.078 is for the acid. dm cube for the acid, and the volume of the acid, which is given to us too, and we have it to be this equal to 30 cm cube. And the next thing we have there is the volume of this one, VB, stands for the volume of the sodium trioxocarbonate, which is 25 cm cube. Now the next thing we have, we're looking for the concentration. We're looking for the concentration of the trioxocarbonate. This one we don't know which, we are going to calculate it, and their ratio from our chemical equation. From this chemical equation, we find out that the A is equal to, for the base, for the acid we have 2, for the B, which is trioxocarbonate, we have 1. So then if we substitute this, we're going to substitute it now to see what we get there. So by substitution, what we have A to be 0.04 times 30 all over times 25 1 over 2 over 1. So when we first multiply this, everything here, we multiply the 1 up, we have 50 CB equal to 0.078 times 30. So but when we carry this over, dividing both sides by 50, we have it to be 0.075 1 times 50. That will give us 0.07447 mole per dm cube. That's the concentration of the trioxocarbonate in mole per dm cube. So the next one we're going to find out now is the mass concentration in mole per dm cube. Since we have this, and we also know, I want you to pay attention to this now. That is, you know that since we have it in mole, we know that 1 mole of what? Sodium trioxocarbonate. 1 mole of sodium trioxocarbonate contain 106 grams. Then this other one, 0.047 mole of sodium trioxocarbonate will contain 106 times 0.047. That will give us 4.97 gram per dm cube. That's the mass concentration of this trioxocarbonate. We'll be able to get the concentration in mole per dm cube, which is this, and then we are also able to get the mass concentration, which is 7.9 gram 97 gram per dm cube. Thank you so much for watching and for getting to this point. I want to thank you for being able to get to this point. I want to encourage you to take advantage of whatever you may have learned from us. Share, subscribe, and if you really want to talk to us, you go to our channel description. Then you can also follow our page on Facebook. There you will be able to chat with us one-on-one. You can also make contact with us via calling. Understand? So it's so good to have you around. Thank you so much for your time.